In the world of AI, it feels like the race has always been about building the biggest, most massive model possible. But what if that's the wrong race entirely? Today, we're diving into a truly groundbreaking AI called EVA-02, and it's here to prove that sometimes smarter really is better than bigger. Because, let's be real, there's a full-on technological arms race happening right now. All the biggest labs on the planet are locked in this fierce competition to build the most powerful AI. And for years, the answer to this question seemed, well, pretty obvious. But what if that whole answer was just wrong? What if the key to winning wasn't about building the biggest weapon, but the cleverest one? Okay, let's get into it. To really get why EVA-02 is such a huge deal, you first have to understand the problem it's designed to solve. And that's what we're calling AI's billion-parameter problem.
For the past few years, the whole field has been absolutely dominated by this one idea, known as scaling laws. Basically, the thinking goes like this. If you just keep throwing more resources at a model, more parameters, which are kind of like the knobs an AI can tune, more data to learn from, and just sheer, raw computing power, you will get a better AI. And hey, to be fair, it worked. For a while.
But this obsession with scale, with just getting bigger and bigger, has created a massive wall. Training these giant models costs millions upon millions of dollars. It basically locks out universities, smaller research groups, pretty much anyone who isn't a tech giant. It's creating this huge divide that actually slows down innovation for everyone else. And that is where the hero of our story comes in. EVA-02 is an AI model that was designed by researchers at the Beijing Academy of Artificial Intelligence, and they came at this with a totally different philosophy. And I mean, just look at this comparison. It is night and day. On one side, you have the giants with their billions of parameters and their colossal private data sets, and on the other, you have EVA-02, just 304 million parameters and trained only on data that's publicly available to anyone. It really is the underdog, built for everybody. So the big question is, how'd they pull it off? How can a model that's so much smaller not only compete with the giants, but in some cases actually beat them? Well, it all comes down to a really, really clever recipe for training. The researchers really zeroed in on these three things. They optimized the architecture, they used a brilliant training strategy, and they were just incredibly thorough. But it's that second one, learning from a master teacher, that's the real secret sauce here. So EVA-02's training is built on this technique called masked image modeling, or MIM. Just imagine showing the AI a photo of a cat, but you've blacked out a big piece of it. The AI's job is to figure out what's in that missing chunk. You make it do this millions and millions of times, and eventually it starts to build this deep, intuitive understanding of what the world is supposed to look like. But here is the absolutely brilliant part. Instead of just trying to guess the missing pixels, the smaller EVA-02 model, let's call it the student, was trained to match the insights of a giant teacher model. Think about it like this. A great art student doesn't just copy a masterpiece paint by numbers. They're learning to see the world through the master's eyes. They're learning about composition, light, and texture. In the same way, EVA-02 basically absorbed the wisdom of a much bigger AI without needing to be massive itself. Okay, so the theory is super clever, but does it actually work in practice? Well, this is where the story gets really, really exciting. The researchers call it a giant killing act, and believe me, they have the numbers to back it up. All right, let's get into the results. First, let's talk size. EVA-02 has over 700 million fewer parameters than the last big model that came out of the same lab. That is a massive, massive reduction in size. But here's the real kicker. Even though it's so much smaller, it's more accurate. On a really important industry benchmark, it scores almost 2% higher. So it's not just smaller, it's objectively smarter. And isn't just outperforming its own family members. Look at how it stacks up against the competition. This model here, BEIT3, is an absolute monster with nearly 2 billion parameters. And yet, little EV-02, at a tiny fraction of the size, still comes out on top. It is flat out better than models that are many, many times larger. Now, let's talk about what might be the ultimate test for an AI's intelligence, something called zero-shot learning. This is where things get really interesting. It's kind of like if you showed a model thousands of pictures of horses, told it what stripes are, and then without any other training, asked it to identify a zebra. It's a true test of whether an AI can generalize and understand concepts, not just memorize pictures. And this is where it gets mind-blowing. This chart compares EVA-02 to OpenClipG, a model that is 6 times its size. And in this incredibly difficult zero-shot test, the much, much smaller EVA-02 actually scores higher. That is a stunning result. It completely flips that whole bigger is better philosophy on its head. And all of this brings us to what I think is the most important part of the story, what it all means for the future. Because this isn't just a technical achievement, it's a philosophical one. So why is this such a big deal? Well, because it proves that you don't need a tech giant's budget to do world-class, state-of-the-art AI research. By focusing on smarter techniques, instead of just brute force, we can put these incredible tools into the hands of way more people. University labs, scrappy startups, maybe even individual developers. It just opens the door for a whole new wave of innovation to come from anywhere and everywhere. You know, the researchers themselves said it best in their paper. Their whole goal was to democratize access, to level the playing field so that the next great idea can come from anywhere, not just from the labs that have the deepest pockets. Which really just leaves us with this one final, pretty exciting thought. EVA-02 isn't just a new model, it's a new recipe, a whole new playbook that shows us how to build incredibly powerful AI way more efficiently. So if this is what one small team can do with this recipe, what happens when everyone can get their hands on it? What kind of breakthroughs are just waiting around the corner?